Hello everyone. In today's video, we are going to cover Chapter 11, Section 6, Areas of Circles, Sectors, and Segments. After studying this section, you will be able to find the areas of circles, find the areas of sectors, and find the areas of segments. So we know the area of a circle formula already. The area of a circle is equal to the product of pi and the square of the radius. So area of a circle is pi r squared, where r is the radius. Now looking at the area of a sector, the region bounded by a circle may be divided into sectors. So a sector of a circle is a region bounded by two radii and an arc of the circle. So in my diagram, I have sector HOP. Just as the length of an arc is a fractional part of the circumference of a circle, the area of a sector is a fractional part of the area of the circle. So, Theorem 108 shows us the area of a sector of a circle is equal to the area of the circle times the fractional part of the circle determined by the sector's arc. So, we want to find what portion the sector is of the entire circle, then multiply that by the area. So, area of sector HOP would be the measure of the arc HP divided by the entire circle's degree measure of 360 multiplied by pi r squared, where r is the radius and arc HP is measured in degrees. Now the area of a segment, another way of dividing the interior of a circle, produces a segment. A segment of a circle is a region bounded by a chord of the circle and its corresponding arc. By studying the diagram above, you may be able to see what to do to find the area of the segment. Sample problem 4 will illustrate the procedure in detail, but if you don't notice what we can do, we can draw in our two radii and notice that would make a triangle. So I can find the area of my entire sector and subtract that from the area of the triangle I just created to find the area of my segment. Looking at some example problems, I have problem 1. Find the area of a circle whose diameter is 10. So I know area of a circle is pi r squared. So I need to find out what my radius is. Well, I'm given a diameter of 10. That means my radius would be 5, because remember, diameter is 2 radii. So area is pi r squared, so 5 squared times pi. 5 squared is 25. So my area of this circle would be 25 pi units squared. Problem 2, find the circumference of a circle whose area is 49 square units. So I know circumference of a circumference is 2 pi r, or pi times diameter. So I need my radius or my diameter to find the circumference. Well, I'm given the area, and I know area of a circle is pi r squared. So if I plug in 49 pi into this formula, I can solve for my radius. So I know the area is 49 pi. That will be equal to pi r squared. If I divide by pi, my pi's will simplify to 1. So I'll have 49 is equal to r squared. To get rid of my exponent of 2, I'll square root. So r will equal 7. So my radius is 7 units. Plugging that into my formula for circumference, c will equal 2 pi times 7, which will be 14 pi. So my circumference is 14 pi units. Problem 3. Find the area of a sector with a radius of 12 and a 45-degree arc. So I know the area of a sector is equal to the fractional portion of the entire circle that the arc is. So the measure of the arc divided by 360 multiplied by the area of the entire circle, or pi r squared. So notice I can plug in the radius of 12 and my 45-degree arc into my formula to find out the area of the sector. So the area of the sector will equal 45 divided by 360 multiplied by my radius of 12 squared times pi. Multiplying this out will give me 18 pi units squared. So the area of a sector with a radius of 12 and a 45-degree arc will be 18 pi units squared. Problem 4. The measure of the arc of the segment AB is 90. The radius of the circle is 10. find the area of the segment. So remember, area of the segment is the area of the entire sector subtracted from the area of the triangle that we can create from the two radii that we can draw in. So if I draw in my two radii and label those both as 10, I can see that I have this whole sector and then the new triangle that I created. So I know the area of this segment will be equal to the area of the sector subtracted from the area of the triangle. So I want to find the area of my sector and subtract that from the area of my triangle. So if I find the area of my sector, I know it is the fractional portion of the circle, so 90 divided by 360 multiplied by the area of the entire circle, so 10 squared pi. Now my area of my triangle, area of a triangle is 1/2 base times height. In this case, my base and my height are both 10, because remember, the height of a triangle is perpendicular to the base. Since arc AB is 90 degrees, I know this triangle is a right triangle, so I can use 10 as my base and my height. Now simplifying these two areas and subtracting them will give me an area of the segment of 25 pi minus 50 units squared. In this lesson, we learned the area of a circle is equal to the product of pi and the square of the radius. The area of a sector of a circle is equal to the area of the circle times the fractional part of the circle determined by the sector's arc. And the area of a segment of the circle is the area of the entire sector subtracted from the area of the triangle that is created by the chord and the two radii. That's a wrap on this video. We'll see you in the next one.